I'm sure you've heard the news. The future is here, and it's electrifying. On this channel we dive deep into the world of electronics repair and reviews, making tech accessible and exciting for everyone. Whether you're a seasoned pro or just starting out, we've got something for you. From fixing your broken gadgets to reviewing the latest tech, we cover it all with a beginner-friendly approach. Imagine fixing that old smartphone yourself, or knowing which gadget is worth your hard-earned money. Join our growing community of tech lovers where learning and fun go hand in hand. With easy-to-follow tutorials, in-depth reviews, and a splash of humor, you'll be empowered to tackle electronics like a pro. So, hit that subscribe button and turn on notifications, because you won't want to miss our upcoming videos. Let's explore, repair, and reimagine the world of electronics together. Welcome to Electrotechnics, your go-to for electronics. Join our growing community of tech lovers where learning and fun go hand in hand. Alright, let's answer a question you've probably wondered about if you've ever used a computer, a smartphone, or even a calculator. How do billions of tiny transistors build a whole CPU, the brain of your device? Imagine you're at a giant stadium. Each seat in the stadium can flip up or down. Up means yes or the number 1, and down means no or the number 0. Now, imagine billions of these seats. And every time you want to do some math, send an emoji, or play a video, you're telling a bunch of these seats to flip up or down in a super specific sequence. That's basically what's happening inside a CPU, but instead of seats we have transistors. So, what exactly is a transistor? It's a tiny electronic switch. Think of it like a gate that controls whether electricity can pass through or not. If the gate is open, electricity flows, and that represents a 1. If it's closed, no electricity flows. That's a 0. Pretty simple, right? But here's where it gets wild. One transistor alone can't do much. But connect a few together, and suddenly you can build something called a logic gate. Logic gates are like tiny decision makers. For example, an AND gate only turns on if both its switches are on. So if you say, hey, if I have both my homework done and my room cleaned, then I get pizza, you've just made an AND gate decision. CPUs are packed with millions, even billions of these logic gates, all made from transistors. By combining these gates, CPUs start to do real work. Want to add numbers? The CPU uses special circuits called adders, which are just clever arrangements of transistors and logic gates. Need to remember a number? That's what flip-flops are for. Little memory cells made from, you guessed it, transistors. When you load a game or watch a video, your computer breaks every task down into tiny instructions, like add these two numbers or move this data over here. Each instruction gets translated into patterns of 1S and 0S, flipping millions of transistors in just the right order, millions or even billions of times every second. So, in a nutshell, transistors are the tiny switches. Logic gates are the decision makers. You put billions of them together and you get a CPU that can do basically anything you ask, as long as you break it down into tiny, simple steps. Next time you open your laptop, just remember, there's a whole stadium's worth of tiny switches working together to make the magic happen. Thanks for watching, and stay curious.